Okay, I ran into an issue yesterday in talking to some folks about the difference between place value and base 10 blocks. So I wanted to show you this. Right here, I have place values of hundreds, tens, ones, and I want to use dots to represent the number of the number in each digit. For example, the one dot here means I have one in the hundreds place. The two dots here means I have two tens. I see I have 100, I have two tens, and I have three ones. So in other words, this is the number 123. And this is how our place value system works. And you can find videos on representing dots on place values like this. For example, here's one. Let me bring this over and show it to you. So you can Google search place values and dots, and like this particular person here, if you watch this video, is showing how to add the numbers 579 plus 347. And when you watch it, he moved one of these dots up here to get a group of 10, and that left him a total of 16. And here you can watch some of it, but so this is the regrouping that you would see in a typical class where you're learning place value. Place value is very important. For example, Roman numerals do not have place value. Like, for example, for Romans to write the number 6, they had to use two digits, right? A V and an I for 6. And place, there was a number for 100, a C, and so on like that. I mean, if they had place value, if the Romans had place value, then there would be a number like this, which would mean 55, but it doesn't in Roman numerals. In fact, there is no such thing as VV because there is no place value. They also are missing the number 0, but we do, and it's a major step forward to have place values compared to not having place values. Without place values, you wouldn't want to be working with Roman numerals to do the scientific stuff that people do in a modern era. So, but we start off with kids with base 10 blocks. Like, for example, to show this same number with base 10 blocks, we would show 123, something like this. We would take the 100 block here, because this is a 10 by 10 square, so that's 100. And then 20, we'd bring over two of these, 120, and then 3 with 1, 2, 3. And you can find a lot of base 10 blocks that you can do this with, right? 123. And you can even show that if I'm adding on numbers to this, let's say that I wanted to add 11 to this. Well, then I would add, if I wanted to add, let's say we wanted to add 8 to this. Well, I'd have to add 8 dots down here, and then I would regroup them, real similar to what the person did on this right here with the dots and the place value. My problem is that not very many of these, but some of these allow you to show grid lines. So let me show grid lines here a second. Now when you look at this, ones, tens, hundreds, thousands, it looks a lot like place values over here. If I would go to the next one and say thousands, it'd be exactly like that. But when you watch videos of people working this, they don't use this the way that we use place values. And place values are up there, very important, right? So you would be thinking, well, the way to represent this, if this is the thousands place, this is the hundreds, this is the tens, and this is the ones, we would say this is 100 and 2 tens, right? 2 tens and 3 ones, just like I did over here and just like you saw on that video I brought over. Because now you have place values. But I want to show you a standard video that you see all the time on this stuff. So here's base 10 blocks right here. And this one here I clicked on is like many of the others that don't have grid lines. And my problem is with the grid lines. So I'll show you this video right here. It's in the middle, getting right to the point of it.
Base 10 blocks are useful for demonstrating place value concepts.
Place value.
I have a couple options before I start here. I can choose to show this ones to thousands grid or not show it at all. If I do show it, I can choose range, so I can either work with this from ones to thousands, or if I choose the second option, click go, you can see I can do decimal numbers from thousands up to ones. I'm going to choose to keep the ones to thousands grid on for right now. And like many of our other virtual manipulatives, I can drag these out into the field here to model a number. If I have the number 135, take 5 ones cubes, 3 of the tens rods, 100 grid.
So this is where the issue is now we have 3 tens in the tens place. So 10 tens is 100. This is 3 tens. So this actually represents 300 right here. This is 100 hundreds. And 100 hundreds is actually 10,000. So this number would actually represent something like 10,305. So that's my issue with this. Now, what's really going on here is semantics, is because these are buckets. They're not place values. This is just saying, this is the place that I want you to put your hundreds, this is the place I want you to put your tens, and this is the place I want you to put your ones. Not place values, but they look exactly the same. So I would recommend that if you show this, you don't use this right here, okay? Don't use the grid. You can use lines to separate them, okay? But don't put these things up here. Because after all, if we're doing this on our area here, we could say, let me not show the grid line. We could show 123 this way. We could show, here's 100, here's a 10, here's a 10, here's a 1, here's a 1, here's a 1, and we need to probably organize them. I mean, this is kind of similar to how somebody would say, oh, well, I got 10 plus 100 plus 1 plus 10 plus 1 plus 1, which is a very sloppy way of saying this, but basically you'd probably organize it first and say 123, right? Arrange them a little bit to make them neat. It even reminds me of how people write polynomials in different orders. Like, for example, you could write this polynomial, 2x squared plus 3x plus 4, as being, first of all, you could write it in a different order, not standard form, 3x plus 2x squared plus 4. And you could even say, let's break it up a little bit. We could have an x plus a 2x plus 3 plus x squared plus a 1 plus another x squared. So we're just breaking it up and not having it organized. So it's nice to have it organized from highest to lowest, and that's fine. That's what that means. But when you turn that grid on, now it looks like place values, not buckets. It looks like place values. So I would say I like other types of these online place value things that don't show all these dots and so on. So sort of like this, and here's one that goes up to the thousands, and you can bring it up here and say, okay, maybe I got 2,101. 2,101. So I just think the grid lines are causing trouble. And look, down here, they didn't, in this area, they don't show that these blocks in here. They're actually showing the value, 2,101. That's nice. This does both things of this with showing place value and it does this too. This one, I don't see that. Now it does have a pencil that you could write it in, but that would be fine. Like if we put in 120, just let's say 120. So now I could get the pencil and I could write in something like, oh, that's 100. Let's see if we got it there, 120. Now there's nothing here, so I have to represent that with a 0, which means I have no ones here on this. And that's what the Romans didn't have. They didn't have a way to represent 0. But there's your number 120. That's a good way of doing it. So anyway, just wanted to show that, and I'll stop it right here.